Okay, so this problem says the current supplied to an air conditioner unit is 4 amps. Okay, so by the way, so here's a quick way to calculate the power. Power supplied to the AC is V times I. It's supplied at 120 volts. I think, yeah, to the AC it's not 240, it's 120. 120 times 4 is 480, 500 watts. So an AC uses the power 5 times this bulb. Okay. And that's what your wattage on your fridge is. So those are the two main hogs in your homes. And your water heater.
Isn't it 240 then for an air conditioner?
Alright, so that's 1,000 watts then. Okay. Alright, so what's that?
So that's why the electric bill is so high in the summer, because you're always using the AC.
Right. What do you set your temperature at?
78.
Huh?
78.
Good. You're wise. Wise beyond your years. The current supplied. The air conditioner is wired using a 10 gauge diameter wire. The charge density is, so this is the charge density in a copper wire typically. See that? That's 10 to the 29 electrons per meter cube. This much copper has 10 to the 29 free electrons, where each copper atom has let go of 2 of its electrons, something like that. Okay? Find the magnitude of the current density and the drift velocity. All right, 4 amps current is, so if you look up the expression, the current density, current is given by N times the charge of the carrier being the electron, so that would be the charge of the electron, times the drift velocity, times the area of cross-section. Okay, they give us the diameter of the wire, so we have the area of cross-section. They give us the density, we know the charge, so and we know the current, so we can calculate the drift velocity. Okay, so the drift velocity of the electrons is I divided by N QA I divided by NQ, and Q is, we'll replace that by E pi R squared. So that's the average speed at which the electrons move. Okay, so let's put everything in. 4 amps N is 8.48 into 10 to the power of 28 per meter cube. The charge of the electron is 10 minus 19 coulombs. And pi R squared. The diameter is that, so 1.284 millimeter into 10 minus 3. I'm running out of space. 284 square. Alright, so let's take care of powers of 10 first. That's 28 minus 19, that's 9. And 9 and 6 is 9 minus 6 is 3, and we'll bring that to the top, so that will become 10 minus 3. And everything is in SI units, so this is the velocity. So what should work out is the unit should work out to meters per second. And so this is already a good thing. 10 minus 3 meters is millimeters, is the velocity is of the order of millimeters per second, which we knew was correct. Okay, so the drift velocity is coming of the order of millimeters per second. So let's take care of the other factors. 4 into 8.48 into 1.6 into pi into 1.284 squared. All right, looks like I've accounted for everything. Okay, so 4 divided by okay, so the drift velocity, well, it's 5/100ths of a millimeter per second in this case. Okay. So by the way, and you guys remember, if you double the current in the AC, all you're doing is doubling the drift velocity. Everything else will be the same. Okay, so in that same air conditioner, if you double the current, all you're doing is doubling the drift velocity. Okay. Oops. Oh. Oh, they asked you the current density and the drift velocity. Okay, I calculated the drift velocity. Okay. So this is part B. A is easy. Current density is just I over A. Okay, that's easy. You guys can do that. Okay.